Welcome to my video lecture on Semiconductor Insulator Conductor. Let us see what is meant by the conductor, insulator and semiconductor. Before that, we have to see the structure of atom. So at the center, this is the nucleus. This nucleus containing the positive and neutral element. Neutral element is called as neutron, whereas positive element is called as proton. So electrons are revolving around this nucleus. This is the electron having the negative charge. So electron is revolving around the nucleus and electron having its own numbers, its own energy. Neutron and proton are present at the nucleus, which is present at the center of atom. Associative energy of the electron. Now consider the electron which is present. This electron is present in the first cell. Now consider the second cell. So this electron is present at the second cell. For sake of simplicity, let us assume that E1 is present at cell 1 and E2 is present at cell 2. At this case, you just remember that the energy which is associated with E1 and the energy is associated with E2 is known as associative energy of electron. So the actual energy that electron has, that is called as associative energy. We know that the associative energy of the electron which is present at the shell 2, that is E2, is more than the electron which is present at the cell 1. So the higher shell means the electron present at the higher shell having the more associative energy. Now what is the energy band? Now we know that there are millions and billions of electrons present in the material. So we have to calculate the energies. So on the basis of individual atom, we could not have the figure which represent the actual energy levels. So that we are categorize the energy into the number of shells. The first shell electron having its energy level, the second shell electron is having its own energy level. So outermost shell, it is called as the valence shell, and valence shell electron is having its own associative energy. So if we combine the electron present in valence shell and if you prepare the cluster of all energy levels, we have to prepare the cluster of all energy levels when the electron is present at the valence shell. So that is the cluster of energy level of individual electron which is present at the particular shell. It is known as the energy band. So energy band is representing the band of energy. So energy band is representing the band of energy. So we have mainly the two band, valence band and conduction band. Now let us see what is the valence band. The electrons which is present at the outermost cell, this is the nucleus and this is the outermost cell, this is called as the last shell, that is the, and this electron is known as the valence shell. Number of electrons are known as the valence shell. So at the outermost shell this electron is present, that is at the valence shell. Now the associative energy at this electron is higher than the first shell, second shell and third shell of that particular atom. Now if we provide the energy to this atom in the form of light or in the form of heat, if we provide the energy in the form of light and heat to this electron which is present at the valence shell, then the associative energy of this electron increases. And if the associative energy or individual energy level increases, then the binding energy of this atom, then this atom going to free from this atom, and that atom loses one electron or loses that electron, and that electron goes into the, now this electron is become free. So as this electron is become free, this is used for the conduction, so that electron jump to the conduction band. So the energy of cluster of energies of all free electrons are known as the conduction band. So the valence band and conduction band. We have to understand on this graph, this represents the energy. This energy is measured into EV, electron volt. Now we have the band, the first cell band, second cell band, third cell band. Likewise that the higher band is the valency band. So this is the valency band. This valency band or valence band is the cluster of, the valence band is the cluster of all energies of the electron which is present at the valence shell, and it is represented by this highest energy level of energy band is represented by EV. So highest energy of valence band is represented by EV, whereas when the electron become free and the cluster of all energy levels of free electron is known as the conduction band. So energy cluster of all free electrons are known as the conduction band. So this is the conduction band, and this level, that is lower conduction, this is the lower level, lower energy of conduction band. This is represented as EC. So EC is the energy level of lowest energy level of conduction band. EV is the highest energy level of conduction band. So there are two bands, conduction band and valence band. In between that there is the energy. Now you look at this energy. This energy is mainly known as the forbidden energy gap. So this is known as the forbidden energy gap. So forbidden energy gap is simply EC minus EV. So EC minus EV is the forbidden energy gap. So this is also known as the band gap energy. This is also known as the band gap energy. So we have the valence band and conduction band. Also we have the band gap energy. So this energy is the band gap energy, and which is given as EC minus EV, that is equal to EF. Now this is called as the band gap energy. So energy gap between the conduction band and valence band is known as the band gap energy. Now here EC minus EV is simply known as the band gap energy, and on this basis of band gap energy we can categorize the material as insulator, as conductor and semiconductor. So we have the classification of material on the basis of band gap energy. In this case, if band gap energy is more, if EF is higher, mainly suppose if band gap energy is EF is suppose is higher, that is greater than 5 EV, then this is called as the insulator. So insulator is a material that does not allow the electron to flow through it. So it resists the flow of electron. So that is called as the insulator. If there is no band gap energy, if valence band and conduction band is overlapping with each other, means there is no energy, band gap energy. So at that case, we know that the conduction band and valence band, in some cases they are overlapping with each other. That is called as the conductor. So in conductor, the band gap is absent, and in case the conduction band touches to the valence band, or it is overlapping with each other, that is called as the conductor. And when this band gap energy, that is the EF, is nearly equal to the 1 eV, then this is called as the semiconductor. When it is nearly equal to the 1 eV, that is called as the semiconductor. So the conductivity means what? The property of material that allows the electron to flow through it, that is called as the conductivity. And hence the conductivity of conductor is higher. So the conductivity of conductor is higher than any other material. So this conductor, the conductivity is higher. So sigma, if it is denoted as conductivity, then the conductivity of conductor is higher, whereas the insulator does not allow current to flow through it. So it opposes the flow of electron. So the conductivity is 0 in case of insulator. What about the conductivity of semiconductor? In case of semiconductor, the conductivity lies in between insulator and conductor. It means that the property of semiconductor changes, its conductivity changes depending on the temperature. At low temperature, the semiconductor acts as insulator, and when temperature increases, the number of hole pairs are increases, and due to that the conductivity increases. So as temperature increases, conductivity of semiconductor also increases. So it means that the semiconductor shows the properties in between insulator and conductor. Mainly we have the conductivity is inversely proportional to the resistivity. So rho is known as the resistivity. So here the resistivity, that is representing as the conductor is having very low resistivity, the insulator is having very high resistivity. The insulator is having very high resistivity, whereas the resistivity of the semiconductor lies in between those of insulator and conductor. So in summary, we know that we have the three type of material: semiconductor, insulator and conductor. The conductor allows current flow through it, whereas insulator does not allow to current flow through it. Whereas the semiconductor has the property in between insulator and conductor. And here we have the band gap energy. So band gap energy, the band gap is more in case of insulator, that is greater than 5 eV, whereas in conductor the band gap is absent, and in some cases the conduction band and valence band are overlapping with each other. Whereas in insulator, in case of the semiconductor, the band gap energy is nearly equal to 1 eV, and it shows the property of both insulator and conductor. So it is called as the semiconductor. So semiconductor shows the property in between insulator and conductor, and property of semiconductor depend on the temperature. So thank you for watching my video.